Hey guys, here's the review for your final exam. I'm going to go through probably every other problem here because we don't necessarily need to go through multiple examples of the same thing. But let's get at least a couple in to make sense of things. First up, we have graphing some exponential equations. And I'd like to look at this in terms of plugging numbers in for a table and choosing good numbers to make sense of this. Our goal is to make our exponent equal to -1, 0, and 1 to give us some nice numbers. But realistically, if you plugged in any numbers, those would be totally fine to do. To get -1, I'm going to plug in -2 because x plus 1 is our exponent. If I plug in -2, I get, well, -1. If I plug in -1, I get 0, and if I plug in 1, or if I plug in 0, I get 1. The other thing I'd like to take a look at before I even begin graphing this is the asymptote. In this case, we're going to be at +1. So I'm going to draw that in, and y equals 1 is going to be my horizontal asymptote there. Plugging these points in. If I plug -2 in, well, we end up with 1/2 to the -1, which is 2. -2 times 2 is 4. -4 plus 1 is going to be -3. So -2, -3 is going to be our first point. If I plug -1 in, we get 1/2 to the 0, which is 1. -2 times 1 is -2, plus 1 is -1. -1, -1 is our second point. And if I plug in 0, we get -2 times 1/2, which is -1, plus 1 is 0. My graph is going to curve something like this to finish off our graph. The domain of this graph, like the domain for all exponential equations, is going to be all real numbers. The range of this graph is going to be based on the horizontal asymptote. It's going to be that, sorry, it should be just a normal r instead of the r that means all real numbers. The range of this is going to be everything less, I don't know why I wrote a 3, 1. So y is less than 1 for this graph. For number 2, I'm going to do the same thing. I'm going to build a table, and I'm going to try to make my exponent -1, 0, and 1. The values I'm going to choose for that this time are going to be 1, 2, and 3, because if I plug those in, that makes the exponent -1, 0, and 1. If I plug 1 in, we get 3 times 1/2 plus 1, which would end up being 2.5. If I plug 2 in, we get 3 times 1 is 3 plus 1 is 4. If I plug 3 in, we get 3 times 2 is 6 plus 1 is 7. Next thing I'm going to do is make my horizontal asymptote, which is going to be a +1. Again, whatever the last value is. Plugging these points in, we get 1, 2.5. We've got 2, 4. And we've got 3, 7. This graph is going to look something like this. The domain, just like for all exponential graphs, is going to be all real numbers. I don't know why I'm spelling things wrong with extra L's. So all real numbers, otherwise known as that fancy R. The range is going to be all y values greater than 1 because we're sitting on top of 1, which is our asymptote. Next up, we got to solve some exponential equations. If you take a look at these are all going to be equations based on the same base. So for example, if I'm taking a look at number 5, 64, 1 over 16, and 16 could all be rewritten as a base 4. So 4 to the third, 4 to the -2 to the -2k is equal to 4 to the 2, 2k minus 2. There are other ways we could have set this up. You could have used 2 as a base, and that would have been okay. You could even have used 16 as a base with some fraction exponents, and that would have been okay too. I'm going to combine some things before I get too far ahead in this, and I'm going to write this as 4 to the 3 plus, and then -2 times -2 is going to be 4k. On the other side, I'm going to have 4 to the 2 times 2k is going to be 4k, and then minus 4. When I set these equal to each other, so we get 3 plus 4k is equal to 4k minus 4. When I solve this, I end up getting 3 equals negative 4, which means that there's no solution. We can do number 7 next. 7 is 8 and 32, both of which can be written as powers of 2. So we get 2 to the third to the negative 3b is equal to 2 to the 5th to the negative 2b minus 2. I'm going to combine these exponents to get negative 9b is equal to negative 10b. 5 times minus 2 is minus 10. I'm going to add 10b to both sides, and I get 1b is equal to negative 10, and we are done. For number 9, we've got to expand this logarithm, and I'd like to recall some stuff that we do with this. If I'm multiplying on the inside, it's going to be written as adding logs together. So I can write this as log base 4 of c plus log base 4 of d plus 1/3 exponent. It's going to come down front. 1/3 log base 4 of a plus, it's over the b also, 1/3 log base 4 of b. That's as expanded as that can get. For number 10, we're going to do a similar thing, but when we're dividing, we subtract the log expressions. I'm going to break this down a little bit more than I broke the last one down. So we're going to have ln of u squared minus ln of w minus ln of v to the 5th. Now I'm going to move these powers down in front. 2 ln of u minus ln of w minus 5 ln of v. Next up, we're solving some more equations. These ones are going to be based on using logarithms or equations that have logarithms in them. As a general rule, we want to get the weird part by itself first and then work from there. I might start this one off by adding 4 to both sides. So we get negative 8 times 5 to the 6n plus 4 is equal to negative 76. Dividing both sides by negative 8. And we get 5 to the 6n plus 4 is equal to 2 negatives divided as a positive. I can reduce that a little bit. 76 divided by 2 is 38. 8 divided by 2 is 4. I can reduce that more to get 19 over 2 is fully reduced. Looking at this problem, I'm going to convert this now to log base 5 so that I can get that n by itself. So we got base, we've got exponent, we've got answer. And in converting this to log form, that's going to be log base 5 of 19 over 2 is equal to 6n plus 4. Finishing this up, I'm going to subtract 4 to both sides. So log base 5 of 19 over 2 minus 4, and then divide both sides by 6 to get the n by itself is equal to n. Jumping down to number 17, we're going to do the opposite. We're going to get the log part by itself, and just that part. I don't know why I circled the 7. And to do that, I'm going to subtract 6 from both sides and divide by 7. Subtracting 6, I get negative 14. Divide by 7 is going to be negative 2 is equal to log base 12 of negative 2a minus 3. I'm going to convert this to an exponential. Here's my base, my exponent, my answer. So 12 to the negative 2 is equal to negative 2a minus 3. If I add that to both sides, we're going to have 1/44 is equal, or plus 3. That's all divided by negative 2 is equal to a. That'd be fine to leave your answer like this on a question like this, or give me a decimal, and that would be okay too. Next up, we've got some log graphs. To do this, the first thing we did was convert these things to exponential. So we did y minus 2 is equal to log base 4 of x plus 4. We converted this to an exponential graph. So that was 4 to the y minus 2 is equal to x plus 4. And then I got the x by itself. 4 to the y minus 2 minus 4 is equal to x. We're going to make an xy table. And this time I'm going to plug things in for y to make them -1, 0, and 1. Good numbers to plug in for that would be 1, 2, and 3. When I plug in 1, 4 to the -1 is 1/4. Minus 4 would be -3.75. When I plug in 2, we get 1 minus 4 is -3. And when I plug in 3, we get 4 minus 4 is 0. I'm also going to look at my asymptote. I've got x plus 4, which means -4, is going to be my vertical asymptote here. You might also notice that's going to be here in this problem with a y in the exponent. Plugging these points in, -3.75, comma 1 is going to be there. -3, comma 2 is going to be here. And 0, comma 3 is going to be there. You might notice the beginnings of a curve that looks like this forming. The domain for this graph would be anything that x is greater than -4. The range for this graph would be all real numbers. Next up, we got some matrix math, and some of these might be undefined, some of these are going to have answers. When I'm adding things together, I need to make sure they have the same dimensions, and all three of these pieces do, and then I'm just adding across. So this would make -6x plus 2 plus y minus 3y. On the bottom, -4y plus 5 minus 0. When I combine some like terms, we get -6x plus y minus 3y minus 2y plus 2. And -4y plus 5 on the bottom. For number 26, when we are multiplying matrices, we're going to multiply row by column. And the first thing I might do is row 1, column 1. So that's row 1 and column 1. I'm going to multiply these things together and do 2 times -2 plus 6 times -2 plus 5 times +2. I might then do row 1, column 2. And in doing that, we're looking at these guys. So that's 2 times 2 plus 6 times -2 plus 5 times -1. We might do row 2, column 1 now. So that'd be -2 times 1 plus -2 times 0 plus 3 times 2. And row 2, column 2. So now we're looking at 1 times 2 plus 0 times -2 plus 3 times -1. Okay, I'm going to add all these things up. So row 1, column 1 would be -4 plus 6. I'm sorry, -4 plus -12 is going to be -16 plus 10 is -6. Row 1, column 2 is going to be 4 minus 12 is -8, minus another 5 is -13. Row 2, column 1 is going to be -2 plus 0 is -2 plus 6 is going to be 4. And row 2, column 2 is going to be 2 plus -3 is -1. Finally, I'm going to build my matrix. And in row 1, column 1, I'm going to put -6. In row 1, column 2, I'm going to put -13. In row 2, column 1, I'm going to put 4. And in row 2, column 2, I'm going to put -1. These positions correspond with what we multiplied to get there. And finally, a couple quick comments on the last section of your exam, which is the stuff that's based on what you did. If you did some computer science work, there are going to be two options to create animations or pictures using JavaScript. If you were to go through, and I'm going to allow you to do this after you turn the rest of your exam, I'll give you a link to a blank JavaScript page so you can create a picture and then create an animation to make sense of this. Types of skills you're going to have to be able to do. You're going to have to be able to shrink or grow an image. You're going to have to be able to change the location of an image, and you're going to have to be able to make some different shapes. Similarly, if you wanted to do the piece on SQL, you'd be looking at creating some kind of a database with a certain number of elements and asked to create some kind of a function with that, either adding elements of that or figuring out how many of a certain type that you have, similar to your store database project. In the probability and statistics area, I tried to look at the easier parts of the statistics course that some of you completed and pull things out of probability, looking at probability based on events that you know the probability of, or we know the total number of outcomes. This is one that you might be able to do even without a lot of deep knowledge of stats, so you probably do okay on this. For the descriptive statistics, looking at calculating the measures of central tendency, mean, median, and mode using a table, and use that information. You've got to be able to also represent that data in some kind of a visual way, and I think it left it up to you as far as what you chose to represent that, and you've got to be able to interpret that type of data representation as well. You don't have to be able to calculate the standard deviation, but you do have to be able to interpret it. So you should know what standard deviation means, although it's okay if you don't remember the formula. You will not be asked to actually produce that. In terms of displaying data, so given some kind of a graph, and I talk about specifically stem, leaf, dot plot, histogram, box, and whisker plot, to interpret the results and explain your thinking. So if you were to go back through the sections on some of those things, that might make some sense of that. For those of you that were preparing for AP Calc, you're really looking at these three sections. Some stuff on equations, and that could be any of the equations that you had to solve from those sections. Stuff on functions, and looking at composition of functions, specifically graphically or using a table, and then sequences and series. So given a sequence, you got to be able to find an explicit formula and find the sum of a series given notation. So series notation, those are the ones that use sigma notation. And finally, if you were investigating some trigonometry work here, you have to solve some hard trig problems. These are problems that involve more than one triangle. So you might see something that's set up like this, where you'd have to make use of lots of different things in order to solve some pieces from that.